Hello everyone, this is Bradley Sward, and this video today is the 2022 Advent of Code Day 15 solution for Part 2 of the problem otherwise known as the beacon exclusion zone. So in Part 1, I basically showed how you could reduce this down to like collision detection when it comes to maybe video games or something like that. Precise collision detection versus imprecise collision detection. And it does get you to an answer, and again, that video is already up there for you guys. And so now for Part 2, and say the part one was easy because the presumption was that the entire range is going to be set, and like from left to right, there's not going to be any holes in there, so you're going to have one continuous range. But for part two, basically you're like, oh man, you knew it was coming. That basically for this time around, there's going to be one hole. One of the lines from 0 to 4 million is going to have one hole in it. Only one is going to have one hole, and your goal is to find that, which means that basically if you reduce down the series of subranges that you have, you're going to have a lot of them, and kind of keep reducing them down into one final solution. You're going to find out that one of the rows, almost every row, every row but one row, is going to have just one final range, which is going to be the entire range, but one of them is going to have a range that has two values because there's going to be a hole between the one side and the other, and those two are never going to resolve because they don't have any values in common in their ranges. So just to say, and then you take that xy value that you find, you do a little bit of math, and you figure out the solution. And so for my solution here, basically a lot of this is the same. But now I'm going through, and I did all this so that I knew what the answer was, so just to reduce down. And again, this is a pretty hacky solution at this point, I got to be honest with you, but it gets the solution done. But basically, I get my series of ranges, and this code here will reduce that down as best as it can into the smallest number of ranges, and hopefully it reduces down to 1. Or 2, and in this case the one that's a 2 here, I'm looking at this code. Let me bring this up a little bit here. This is the code that matters, like that. And when I do something like that, these are the values I get. So this is the y value here, this guy right here, and this is the range, and I know the solution is the number between this one, and you can figure out what that is. So basically, you got to do a little manual work on the tail end, just because I'm too lazy to automate this at the current time. But because why bother? I have my solution moving on to day 16 pretty soon. So now multiply that number by 4 million, and then add this number, and you get whatever it is you get. And it's a giant number. And where is my? Here it is. And when you do that, this is the number you get when you multiply the one number by 4 million and you add the other number to it. So that is the solution. That is how I went about solving this problem, basically reducing a whole ton of subranges into as few subranges as you can. So as always, thanks for sticking it out with me as always, and have a great day, everybody. And I hope to see you guys in future videos.